today I am talking with a spray characteristic of biofuels. Biofuels basically mainly I am talking with diesel perspective, addition of basically ethanol, addition of EB, or basically what happened with pure fuel when we inject the pure biodiesel inside. So definitely I I mean, very much interested when I begin engine research that what happened inside. So that's why basically I incline towards optical diagnostics for the fuels. So my area of interest is basically optical diagnostics. I tried different fuels, biofuels. Basically, I also have some experiences in noise vibration measurement as well as emission measurement and its health impact. So before starting, I like to thank a few laboratories that I worked in. One is Engine Research Lab at IIT Kanpur. KAIST also have an engine lab, and University of Orleans have a Prism laboratory where I did my postdoc. So when I begin, I like to show some spray of different waste cooking oil, biodiesel, Karanja biodiesel, Jatropha biodiesel, and its comparison with diesel in non-evaporative, evaporative condition and actual engine condition. So in this first slide, it is in non-evaporative condition, and we found that there is a higher spray penetration length for basically biofuels compared to diesel. And when we basically did experiment in evaporative condition, this work is conducted at KAIST in South Korea. So in that also we found that so these two both are basically spray in high pressure vessel, high pressure, high temperature vessel, and last images are actual engine investigation inside the basically there is a optical piston, and we inject the fuel, and what happened inside that we measured, and we found that in all these three conditions biofuels have more sooty flame, and another important parameter I observed is that ignition delay for two of the biofuels are earlier as compared to other diesel or waste cooking oil biodiesel. In addition to that, I also conducted droplet size measurement. In this droplet size measurement, definitely it is definitely biofuels have higher viscosity, and because of that there is a higher Sotherman diameter. So we also conducted engine experiment to validate that what is happening inside the when we measure the optically, that reflected in engine experiments or not, and we found that there is a ignition delay of biofuels are less compared to diesel, and you can also observe that soot emission, tailpipe emissions or smoke emissions are higher for the Karanja and Jatropha biodiesel, while it is slightly lower for waste cooking oil biodiesel. Some files are basically not working. Yes. So basically, I conducted. I basically apply diffuse back illumination technique to measure the soot and quantify the soot. Okay. So there are basically images, and we do image analysis to get the information about soot and quantify the soot. This work was conducted at Prism laboratory. So initially, one experiment we did is that there is a we vary Cetan number, and we see that what happens if we increase the Cetan number, and we found that with increase in Cetan number, basically you can see that there is a higher soot concentration observed. Okay. So this higher soot concentration might be due to the basically oxidation will be, there will be always more OH radicals available, and there will be improved in oxidation. So you can see that these higher Cetan number fuel have showing higher soot concentration. And if we compare the lift-off length, then we can observe that lower Cetan number fuel have a higher lift-off length, and with increase in Cetan number, there is a lower lift-off length we observed. In addition to that, there is a soot mass basically increase with increase in it is not. So you can see here basically that there is a increase in soot mass with increase in Cetan. So another experiment we conducted with the basically we can say ECN premix condition, where CO2 as well as H2O also basically added to see the impact. And we can found that if we basically apply EGR condition, then at higher basically at higher Cetan value also there is a decrease in soot concentration. So if we combine the EGR condition, then we can basically address the issue that happened with basically for the higher soot concentration without EGR condition. So another experiment we conducted on effect of ABE and butanol blends on soot. So you can see that with increase in ABE content or butanol content, there is a decrease in soot concentration, and it is also observed that there is a drastic reduction of soot here with the increase of alcohol blends in diesel. Okay, and another important thing we observed that there is an increase in lift-off length also observed. Okay, it is due to the decrease in equivalence ratio and increase in oxidation process of the soot. Apart from that, we also investigated basically CO2 and H2O addition for the soot formation. So here initially what we did, that we did basically 15% oxygen and remaining is nitrogen. So this is a 15% oxygen and remaining is nitrogen. After that we added we increased the addition of CO2, and we see that what happened basically with increase in CO2 concentration. Similarly, we also increase the H2O concentration. We keep oxygen concentration same and decreasing nitrogen concentration and remaining increase in H2O concentration as well as CO2 concentration. And we found that with increase in CO2 concentration or H2O concentration, there is always a reduction in soot observed. But here you can see that soot reduction is basically with lower quantity of or lower quantity of water or vapor also help to reduce soot concentration in much impactful way. So, but with water, there is always we cannot use water because there is a durability issue. So we need to see that how we can implement this. And after that, this is basically we apply ECN premix condition. ECN premix condition is 75.15% basically nitrogen, 6.22% CO2, 3.63% H2O. So by applying this condition, we observed that this is a EGR-like condition, and we found that there is a drastic reduction in soot. So yeah, some conclusion for my work. My work is that biodiesel exhibited deteriorated spray characteristic and diesel showing larger penetration length and narrower spray angle. SMD also observed higher. Karanja and Jethro biodiesel have higher level of soot emissions. Effect of ABE and butanol addition in blends So when we increase ABE at butanol blends, so the combustion phase is delayed and combustion duration reduced and heat release in the combustion chamber is also decreased. So as the auto ignition ability influences flame position, the lift-off length of ABE and butanol blends is longer. Basically, combustion is delayed, and because of that, this lift-off length increase. Soot extension levels are drastically reduced. So there is one more thing that we observed, that with even 20%, we also tried to do experiment with 40% ABE and butanol, but we don't found anything, so we didn't report that. So another is that effect of increase in Chetan number and soot emission. So definitely with lower Chetan number, there is a lower soot. But as I mentioned, that if we want to use higher Chetan number, then if we apply EGR condition, then it is the best way to decrease the soot concentration. So in last, effect of CO2 and H2O addition on soot. So we found that basically combination of CO2 and H2O have 50% reduction in soot. And in addition to that, we found that which is more impactful. So even water vapor have a 20% reduction. So with same quantity of both CO2 or H2O, water vapor is more impactful for reduction in soot. So with that, I conclude my presentation.
Do you have time for some questions? Yes, please.
Chetan, how did you do the calibration for your diffused back illumination for soot calculation?
Basically, we compare the result because engine combustion network have available results, and all parameters remain same. We keep all parameters same. So after that, only one thing change here is that engine combustion network have used premixed. Sun National Laboratory use premixed combustion, so they have CO2 and H2O. And our new one-shot engine that in Prism Laboratory have that facility that we cannot use whatever combination we want, that we use. So generally here calibration is only maybe with compare with the earlier result.
Okay.
Yeah.
So you did at the same condition and then you reproduced it and then use it as
So here you can see that premix condition.
Okay.
I showed premix condition of Sandhya. So we compare that condition.
Okay. So it's tricky then. See, calibration in one condition when we do, in other condition whether it will be.
But engine combustion network keep everything same, just like injection pressure to whatever minute thing, whatever minute injection duration you can say, or you can say fuel injection is basically there is a 60 bar is for spray condition. So we inject the fuel in the atmosphere of 60 bar. So this kind of things we keep similar in engine combustion network. So so that at least we can compare that result with earlier result.
Did you use any thresholding because you are doing the image analysis from the image? Did you use any thresholding to fit the calibration or results from your study and with the reference which you are looking?
Threshold, I'm not getting.
Yeah,
which kind of threshold?
Thresholding of the intensity of the image, because the intensity which you are calculating from your image analysis it can be very changed depending on the thresholding level. There are different thresholding methods to now look into the average intensity of the image.
Just like what I did, that we have information of these processes that we take from other experiment. So we KE is also we took from other experiment because those are the reference value. We use basically KL factor, and KL factor whatever we get is here we do image analysis of ILAD by IO. So yeah.
That's what I am telling.
Yeah.
That intensity can be also changed around.
I agree, but it is a ratio, so
Still, yes.
yeah.
Yeah.
Yeah, I have one question about so when you change the proportion of the effect on soot, you also mentioned the effect on lift of lens. Usually both are quite connected. Like of course if you increase the lift of lens, your soot will decrease. Did you try to connect that, making some calculation of the air-fuel ratio content and the air-fuel ratio at the lift-off to see if it's purely an effect of the lift-off or it's also an effect of the chemical composition?
I think we didn't did that. We just basically I tried to see in literature that what kind of impact is there. And I found that maybe dilution impact, or in water there may be a reduction in temperature, surrounding temperature, but I didn't found any basically what can I say strong reason that I can argue.
Did you measure lift of lens?
Yeah.
Okay. If you have the lift of lens, then you can estimate the air-fuel ratio along the axis, and you can estimate the air-fuel ratio at the lift-off, and you can see if basically the soot formation is related to this or not. Basically, it should be when you increase your lift-off length, then you usually decrease the air-fuel ratio, and then.
Yeah, so I think I didn't need that, but it is interesting to.
We published some results about the link with Chetan about the link with the surface and soot, and I check again if we have a new effect with the composition of fuel with ABE. It's not only a reduction with the lift of lens, but it's the best influence is the lift of lens.
Okay, thank you. Maybe you can enrich your.
Yeah, definitely. This is basically when I found this result. I don't found any connection because there are not this kind of information available. Only information available with it. I mean CO2 and H2 variation. I did a lot of literature at that time, but to find linkage it become difficult. But we can basically discuss.
Also with apparently there is some literature now.
Yeah. Okay.
Just one thing.
Yeah.
In general, if you look at EGR is traditionally considered to be an idea for reducing the NOx.
Yeah.
And on the other hand, your soot goes up. I mean, particulate matter goes up. So that's what the general understanding.
Yeah.
The moment you put more and more AGR, your NOx will go down and the soot will go up. And interestingly here in EGR, the soot is coming down.
Yeah, soot is coming down.
With a high cetane.
But so there is I mean water vapor also play important role that we can say that it play a major role. So yeah, what concentration is basically we can use that basically need to see in actual engine condition basically.
Yeah, because commercially, if you see.
Yeah, so this is
when
basically
BS4
here we
emission
can
norms-
control the conditions.
Correct.
Right.
When
So
I
but in
remember
actual conditions,
when the BS4 emission norms were introduced in this country,
yeah,
nobody wanted to go for the selective cattle pig reduction.
yeah.
And they wanted to manage somehow without SCR the NOx conditions, so they went for a higher EGR. Of course, they had a penalty and the suit, they put the DPF to take care of it.
Yeah.
And now once they moved to BS6, there is no other way, they have put both DPF as well as SCR to take care of both NOx and suit.
Yeah.
So that is, thank you.
Yeah, but I basically I will see how basically what can we do next. Yeah. Okay. Okay. Mm-hmm. No, we didn't measure the flame temperature, but I think we calculated. I didn't remember exactly those values right now. Okay.
Long live India and France friendship.